Amen. Dr. Gibson, welcome to Stone Tower, and we're glad you're here.
Thank you very much. I presume, there we are. I think I hear myself. All right. Well, I've got a remote up here I need to get a hold of. Thank you for inviting me and coming out. It's nice to see you here and nice to be here in Stone Tower in Portland. We have a family that lives out in the gorge, so it's a good excuse to come up. I'll tell you a little bit about my the service that I belong to called Geo-science Research Institute. It's a group of scientists who study faith and science, religion and science, creation and evolution and science. We have a website, which you'll see on the screen, or you have them on the screen here, www.GRISDA, GRISDA. So that's us. And probably our main focus is toward the academic community, the university students and professors, but we have also general interest things there on the website. If you go to the front page, you'll see a little news note, some science discovery with a commentary about it. We change it maybe every week or so, something like that. So we invite you to look at that website. Now tonight I'd like to talk to you about meaning and science. And the title kind of implies, I think, the point, and that is to get meaning out of life, you need to go beyond science. And so I have 3 points that I'd like to make from this presentation. First, I'd like to explore the nature of science with you. What do we mean by science? And how does it work? And it'll be familiar to you. I'm sure you already have studied that. The second point is to show that Christianity and true science can work in harmony. And I suspect some of you are going to be a little bit surprised by some of the things in that section. At least one picture with some people's faces on it and quotations. And thirdly, I want to make the point that to get meaning in our lives, we don't get that from science. We get that from our culture, from our family, from our religion, from our philosophy, from our understanding. It's not the kind of thing that we can do experiments on. It's something that we absorb from our surroundings, and we make choices about it to some extent, but many of us have never really thought consciously about it. We're not really aware that we have these assumptions until someone asks us about it. And if you ever talk to an animist, for example, who believes that there's a spirit in every tree and rock and so on, you might find that you indeed have some assumptions that are quite different from what another person might have. So those are the points I'd like to make. So first we'll start with the nature of science, and we'll look at a classical scientific question that probably all of you studied in high school. An example of an experiment. And that is the question of spontaneous generation. Now the diagram there shows, I think it's from 1605. That's been quite a while now, but apparently at that time, some people at least thought that certain birds came from a tree. This is a bird-bearing tree, if you please. Kind of an odd idea. Others thought that if you take a bowl of wheat, throw in a few dirty rags, out from that will emerge rats. Well, if you don't believe it, try it. See? Probably work. Yeah. And where do flies and maggots come from? Well, if you have a rotten meat, they just emerge from the meat spontaneously. And so those were some of the questions that people were asking a few hundred years ago. Goes all the way back to Aristotle. Aristotle had this idea, and Aristotle has quite a bit of influence. He's had a lot of influence in the past. There's still some influence from the Greeks in our thinking today that we may not even realize that are that old. The idea is maybe just something that's assumed. Well, the question about flies coming from meat was investigated by a guy named Francesco Redi. Redi, I don't know, I wasn't there when he was pronouncing his name, but he tried to disprove that maggots actually came out of the meat. So how would you go about doing that? Well, he took 3 flasks, and one of them he put rotten meat in each one. One of them he left open. One of them he put a little screen on so that nothing large could enter, but it wouldn't stop air from going through. And the other one he sealed. So the one that was open developed maggots. The one that had the screen on top also developed maggots. But the one that was sealed didn't develop maggots. But the explanation for the result was the flies could not get into the sealed one. They could get into the open one, and they could drop their eggs down through the screen on the screen. So that explained there was no spontaneous generation of maggots. And so people said, okay, that makes sense. Flies lay their eggs there. And so they accepted that maggots don't generate spontaneously from meat. But there was broth. That didn't apply to other things. When you have a broth, it spoils and gets cloudy, and that's because spontaneous generation of something is occurring in the broth. And a fellow named Needham wanted to disprove this idea. Let's see. No, he wanted to prove it, sorry. So in 1745, he took a flask of cloudy, spoiled, if you please, broth, and boiled it, and then set it out again, and it got cloudy again. He said, see, if boiling it didn't destroy the principle. It still produces whatever microbes. I don't know how much they knew about those things in those days. They had probably seen a few microbes, but this was pretty early on. Now, Spallanzani, on the other hand, opposed Needham. So you got an argument going. See, this is what science does. You have a point you want to make, and some guy says, okay, I've shown it this way. Another guy says, no, you haven't. I've got an explanation that doesn't match yours. And so the scientists go back and forth until finally everybody's satisfied. Okay, it's been shown now, we're satisfied, and everybody agrees on it. But in the meantime, you can have a lot of controversy. So here, Spallanzani boiled 2 flasks. One of them was sealed. I presume he sealed it after it was boiled. And the other was open. And the one that was sealed didn't generate microbes. Now, would you say that he has proved that microbes don't come by spontaneous generation? They didn't come out when he sealed it, but they did come back when he left it open. So has he proved it? Well, you might think so, but supporters of spontaneous generation said, you shut out the air. You have to have air in order for spontaneous generation to occur. You see, so although it looked like proof, and that's something I think that's significant, what looked like proof to some didn't look like proof to others. So how would you settle this question? To boil the flask and leave it open to the air in such a way that microbes don't just fall into it and spoil the broth. Well, it was the genius of Louis Pasteur that solved this problem. He took a flask with a long neck that had a curve in a trap, you see, a trap in it, and he boiled the flask. Any microbes would get caught in that trap, and therefore the broth wouldn't spoil. But to prove that it still could be spoiled, he took that flask and tipped it over so that the broth ran down into the trap, and then back up again. So whatever was in the trap was now in the broth, and then it spoiled. And everybody agreed. When Pasteur was done, everybody agreed, you've proved it now. It's beyond dispute. The active principle was not destroyed by boiling. You left it open to the air, and we can see now that there's something in the trap that caused the broth to spoil. Now, what do we learn from this? The first thing I would point out is it sometimes can be quite difficult to disprove a scientific hypothesis. Now, you may have heard science is not so much about proving that something is right, because you can never, ever prove that a rule applies to every case, because you cannot explore every case. You take a sample and you can be pretty sure that people will say, well, you've looked at enough, now we agree. But if one exception should happen to come up, then your rule is spoiled. You can never prove something absolutely true in every circumstance, because you cannot create and test every circumstance. But you can disprove something. You can prove that it doesn't work. And so one of the purposes of science in the philosophical thinking about science is not about proof, it's about disproof. So you bring up a hypothesis and you try to disprove it. And if you are unsuccessful at disproving it, then you suspect it might be true. You can't prove it's true, but you can sure make it look like there's no other possibility because you've tried. So that's one of the lessons we learn here. Another one is disproof requires repeatable experiments, carefully designed to test the hypothesis. For example, Needham. Remember Needham? He didn't have a control. He just boiled the broth, let it cool, and it spoiled again. But who knows what was going on? But if you put another flask there, and the only difference between the two flasks is one thing. If you get a different result, then it must be because of that one thing that's different. And that's how this experimental method has really progressed marvelously. Furthermore, our third lesson is you can prove it wrong for maggots, but that doesn't mean it applies to microbes. You see the point there? So it really, science has to be done very carefully, thoroughly, and it should be no surprise to learn that scientists are often in conflict with each other. Controversy in science is fairly normal because it's in the controversial areas that scientists are studying. Scientists are not studying things that are already known or already known to work. Why would they spend their time on that? They're looking for new knowledge, and then they're trying to discover it in the process. They disagree sometimes. So we call this the experimental method. It's not the only method of science, but it's the method that we kind of look to as the icon of how science is doing. It involves the use of two groups, the control group and the experimental group. They're treated alike except for one experimental condition, and that one difference is carefully chosen for the purpose that it can reveal whether the hypothesis that's being tested has been disproved or not. And this is the method that has provided science with its greatest successes, laid the foundation for technological advances, and we're all beneficiaries of this. All of us are very much benefited by the progress of science. Even as we sit here, the control of the temperature, perhaps even humidity of the room, the kinds of materials that you're wearing and sitting on and using, all this kind of stuff has come because science has been very successful. All right, now if we had time, we could go into the historical method and survey method and so on. There's different methods of science. But that's I think, is an explanation of why science works so well, because it's done so carefully. Now let's take a look at the historical and philosophical roots of science. How did science get started? And where? And by whom? Well, in most textbooks, they will refer you back to the ancient Greeks. And fair enough, there are two men especially who had a big influence in this area, Plato and Aristotle. Plato, you may remember, had the idea called dualism. Dualism is the concept that there's a spiritual or mental kind of reality, and then there's a material world. And one common example is that I remember hearing about when I was younger is a chair. What is a chair? Well, you picture in your mind a chair is something that has, a place to sit, a back, some legs, and so on. Well, there's one. Is that a chair over there? Yeah, that's a chair. Well, is that a chair over there? Yeah, but it's not the same as that one over there. Well, what is it that makes it a chair? Well, it's the idea. Plato would say there's a perfect concept of a chair, maybe you could say in the mind of God, or out somewhere in perfection. But what we actually use for chairs are inferior. They're not really ideal. They're just copies of chairs. Now, if you believe that the mental and immaterial, if you please, world is superior and the physical world is inferior, what kind of science would you do? Well, you'd sit around in a circle and think about things, wouldn't you? The mental is where it's at, you see. You would discuss things, and you'd say, well, what kind of movement would a heavenly body have? Circular. Why? Because that's the perfect shape. What kind of shape would the earth have? A perfect sphere, and the moon, and so on. Perfect sphere. Why? Because those are ideal types. Well, you may know later on when scientists looked at the universe, the solar system, they discovered that actually planets have an elliptical orbit, and the shape of the planets it's somewhat spherical, but not a perfect sphere. So that kind of illustrates the influence of Plato on thinking about things rather than actually looking at them. But Aristotle took the other view. Aristotle wanted to see how things actually worked. So Aristotle went out and looked at them. But Aristotle had some primitive ideas like spontaneous generation. He believed the universe was eternal, had always been here and static. And so some of those ideas have persisted and have been slow to be replaced. In fact, if you look at Darwin, in Darwin's day, people believed in what's called fixity of species, that God created the species and they never changed after he created them. In fact, if they were to change, that would mean he didn't create them well enough in the beginning. See? That you see that people thinking about things, but when they actually go out and look at them, they say, well, of course species change. Everybody knows that. You can see it just in chickens. Just where my daughter, we were visiting, has several different kinds of chickens. They're certainly not all the same. And you can say the same for dogs or horses or pigs or cattle or whatever. Certainly there's been change. But what's really interesting is the Greeks never really went beyond approximately where Aristotle was. They never really developed the kind of what we would call modern science. They kind of hit a wall and didn't go any further. And it was in a Christian society, Western Europe, that modern science actually developed. Now, is there some reason why Christians brought science farther than the Greeks did? Well, there are some thoughts on that. It's a little bit controversial because of people having different viewpoints toward the benefits of Christianity. But one of them is that one of the reasons that Christians were free to investigate science in a modern way is monotheism. They believed in one God. The Greeks believed in many gods. Now, if you believe in many gods, then perhaps there's a god of the water and a god of the rocks or earth and a god of the rain. If you have many gods, they're in conflict. So it may be that today the god of rain is angry and starts throwing thunder and lightning around. You don't have any idea why, but tomorrow it may be that the sun god overpowers the rain god and things happen differently. And you could never predict what's going to happen because you don't know what the god's moods are going to be. You get the point? If you have a bunch of gods controlling nature and they all have different moods that change from time to time, then what happens in nature is going to change from time to time, and there's no point in trying to figure out how things work because it's all caused by the gods. But Christians didn't believe that. Christians believe there's one God in charge of all of nature, and that one God is consistent. He's not capricious. He's consistent. And so therefore, we can expect continuity and consistency in nature. So we can study, and what we study will not be because of the God's mood, but because of the one God who ordered things. Another thing is, in Christianity, according to Genesis, when God was finished with the creation, he said it was very good. The creation is good. If the creation is good, then we won't be contaminated by touching it, by moving it around or experimenting with it. It's good. So I guess we could say it's even safe to study nature. Now, the Greeks did not believe that nature was good in the sense that I'm referring to it here. Nature was physical. Remember, goodness is ideas, perfection, not material things. But our world is material. Therefore, how can it be good? So it'd be a waste of time, perhaps, to study it. I'm probably overstating it a little bit in order to make the point clear. Another one is God and nature are different. If you're a pantheist, which most, I think, pagans are close to that, pantheists believe that nature is God. And so if nature is God, then if you were to go around cutting up something, you're cutting up God. You get that? That sounds pretty dangerous. If God gets kind of unhappy with you, who knows what he'll do with you? But Christians believe God and nature are different. You can mess with nature and you haven't touched God. He's not going to get angry just because you're stirring around in what he created. He does expect, of course, us to be responsible. But we can study nature without offending God because we're not disturbing God by looking at nature. Another one that Christianity brings to this story is the belief that God is omnipotent. In other words, if God is omnipotent, that means he is not bound by circumstances to do something in a predictable way, but that he is free to create any way he wants. And if he's free to create any way he wants, then we're probably not going to be able to figure out how he creates just by thinking. Because we have to see, if we want to know how he created, we need to look to see what he did, not just think about it. So that frees us up to do science. Now, here's what I think a lot of people might be surprised to learn. The early pioneers of science were almost all Christians. Science really was founded by Christians. Here's one. John Ray wrote a book, and he lived from 1627 to 1705. He's considered to be the founder of modern biology. The title of his book was The Wisdom of God Manifested in the Works of Creation. Probably wouldn't get a book like that published these days. But in those days, this was a Christian man who founded the science of biology. You may have heard of Isaac Newton, the physicist, 1643 to 1727. And he wrote this in his book, A Heavenly Master Governs all the world as sovereign of the universe. That sounds very much like a Christian to me. And yet he is probably the most famous scientist who ever lived. Johannes Kepler was, by the way, Isaac Newton is regarded to be the founder of modern science. He basically applied numbers to the world. It's called the mathematization of physics. Instead of just being descriptive, he put numbers and wrote equations, making it a mathematical thing, and that gave it much more scientific rigor. Johannes Kepler was one of the founders of astronomy, living in around 1600, plus and minus. He wrote, "Behold how through my effort God is being celebrated in astronomy." He was a believer in God, a Christian man. Robert Boyle, a very famous chemist. If you've ever studied chemistry, remember Boyle's law. And there's an equation, you have some problems to solve, Boyle's law. And he wrote, "I exclaim with the psalmist, how manifold are thy works, O Lord." A very devout believer, and even perhaps more devout than him, although Robert Boyle was pretty devout. But Pascal, a very famous mathematician, wrote, "The conduct of God, who disposes all things kindly, is to put religion into the mind by reason and into the heart by grace." That's a great quote, I think. I really like that quote. But that was Pascal. And there's Pascal's law also, and Pascal's triangle, and many things. These guys were pioneers. They're the ones that founded science. And yet today, we're told that science and Christianity are enemies. They're not enemies. What's enemies is not at all science, but a philosophy known as materialism. Let's look a little bit at the strengths and limitations of science. First of all, testability. We've talked a little bit about that already. In order for something to be considered really scientific, somebody needs to be able to try to challenge it, see if they can prove it wrong. If you can't challenge it, if you can't test it, well, it might be an interesting idea, but it doesn't really fall into the category of science. Well, sometimes people put it there anyway, but in a philosophical sense, that testability is considered to be a very crucial characteristic of science. Another one is repeatability. You may remember some years ago there was some scientists from Utah that claimed they had nuclear fusion in the laboratory. Do you remember that? It's been quite a while now. It made a huge stir because nuclear fusion is what happens in the sun to produce the energy. And that's kind of the holy grail of the energy industry, to try to get nuclear fusion because it produces an enormous amount of energy, much more than what we have now, nuclear fission, I think it is, that we use now. And they claimed that they had produced it in a jar in their lab. But other scientists, of course, they were all excited. If that's the case, there's huge amounts of money to be made, but nobody else could get the same result. It wasn't repeatable. So it was discarded. The idea was considered to be something went wrong in the experiment. Experimental control, we talked about that. Two sets of experiments, one that differ with one particular condition, and you try to link then that condition with the result. Another strength is that science is mechanistic. And by mechanistic, what I mean is science tries to produce a step-by-step explanation of what happened. Perhaps you might know that best in chemical reactions, where they say, first of all, an electron hits there, and then an atom falls off, and then you get an ion, and that attacks this particular part of the ion, the electrons, and that other one they attack, and they break into parts and then recombine. And step by step, they try to explain how that reaction occurs. And also that applies to other sciences as well. A limitation of science. Science has its limitations. It has its strengths and it has its limitations. One of them is data. Here we have an oyster bed, if you can see it on the screen. There's an oyster bed with thousands and thousands and thousands of oysters. Now we want to know what's the average size of those oysters. Are we going to measure every single one and take an average? A person could spend weeks, months, I don't know how long doing that. So what does a scientist do? He samples it. Maybe he'd lay out a little grid over the thing, maybe say 6 inches by 6 inches and over the whole bed, and then he'll take maybe 3 shells from each of those grids just to make sure that he sampled every part of the bed, and then he would measure those. He samples the data. Now, it's been said that on a hillside you may have a paleontologist going up the hillside collecting, let's say, crinoids, sea lilies, if you please. And he's collecting sea lilies, and as he goes along, he's finding wonderful ideas with sea lilies. But when he gets done, somebody may say, hey, what kind of brachiopods did you see up there? Huh? Brachiopods? I wasn't looking for brachiopods. I was looking for sea lilies. So he missed everything except what he was looking for. You get the point? So any scientist who's trying to collect data has some idea of what data he wants. And he may pass right by other data that could be very useful too. There's nothing, that's not a crime or anything. It's just because we're specialized and we look for particular data. But that does limit us as to what we can do. Our sampling may be biased and it may lead us astray. But if we can repeat it several times, we have more confidence in it. Another limitation is some things just we've never really thought of. Before 1980, people used to talk about what made the dinosaurs go extinct. And there were, I remember, 30 different explanations. It was too hot, it was too cold, it was too dry, it was too wet, on and on. People just trying to, the dinosaurs starved to death or they got constipated and died. It was all kinds of silly things. But about 1980, somebody discovered a particular layer right at the Cretaceous Paleogene boundary, certain geological strata that was full of an element called, not full, but it had enriched in an element called iridium, which is rare on the Earth, but more common in meteorites and things. Said, hey, look at this. What made this layer rich in iridium? Probably an asteroid hit the Earth. And if an asteroid hit the Earth, if it was big enough to leave this much iridium, it must have been maybe 5 or 10 miles wide. And if an object that big hit, it would cause a lot of destruction. Where is the crater? Nobody knew where the crater was. But then somebody heard the idea, and they said, hey, we've been doing oil explorations in Yucatan Peninsula, and we've seen a subterranean crater there about the size you're estimating. And so they put things together and say, oh, well, I guess that must be it. So now that's a very popular theory that the dinosaurs were wiped out by an extraterrestrial impact. It's controversial because at the same point in the geologic column where that asteroidal impact structure is, if you go to the opposite side of the world, over in India, there's a huge outpouring of lava called the Deccan Traps. And some have postulated that the asteroid impact caused a wave of energy to go around the world and be focused on the opposite side, antipodal focusing, they call it, and cause the lava to flow. Well, whether that's true or not, I can see. Have I shown you any science in that? Not very much. We are telling stories about the past. I want you to remember that expression. We're telling stories about the past. Because when we get to the conflict between science and creation or the Bible, all the conflict that I have been able to find is when we are telling stories about the past. There is no conflict over the structure of the atom, the force of gravity, the motions of the planets. There is no conflict about DNA and genes. The conflict comes when we try to tell stories about the past. So that's an interesting point. And I think it points out that really it's not science that causes the conflict, but something else. But anyway, in this case, who would have thought that there was a giant asteroidal strike? Nobody believes such things. We'd never seen one. Oh, sure, little meteorites come down once in a while. We could maybe find one this big even, but nothing like this that would change the whole world. Well, that limited what science could explain. And whether that explanation is correct or not is not really the point that I'm trying to make. I'm trying to make is nobody had thought of that idea before that layer was found. Another limitation is testing. We can't, can we test what an asteroid would do if it hit the Earth? Say a 10-mile wide asteroid? Let's see. Let's bring one down. Well, we would never be able to evaluate the results because we'd all get wiped out. So we just can't test some of those things. And some things have only occurred once. For example, could we scientifically test whether God created humans separately? Can we test that scientifically? How would we do that? Hey, God, come here to my lab. Here's some dirt, make a human. Even that wouldn't prove it because you could always say, well, he can do it that way, but he didn't do it that way in the past. You can't test those kinds of ideas. It only happened once, and they're called singularities, something that only happened once. So science is limited when it deals with singularities. Another one, well, we mentioned mechanism. If you have a supernatural cause, of course, we're beyond science there. Here's another point that I would like to make. If you wanted to know how to make an automobile, how do you manufacture an automobile? Couldn't you just go down to your nearest car dealer and say, hey, get the best mechanics you have who know all about the automobile. Bring them here and show me how to make an automobile. Does that make sense? Do you think auto mechanics know how to make automobiles? No, they have no idea how to make automobiles. They maintain them, but they don't manufacture them. It's a completely different process to manufacture an automobile than it is to maintain them. Likewise, it's a completely different process to create a world than it is to maintain a world. So just because we know how nature works today does not give us the answer to how it got here in the first place. Those are really two different questions. Another limitation of science is meaning. Science provides, at least generally, an objective methodology for collecting data. But data can be compared to a telephone book. What's that? Haven't seen one for years, I guess. In the olden days, we used to have telephone books, and you open it up. Maybe you still have them, but You open it up, and here's a list of people and their phone numbers, right? But what's the meaning? So what? It's just this list of data. Do you know any of those people? Well, you might happen to find somebody you know. But that data doesn't actually carry any significance unless you apply it to some kind of question or in some kind of context. For example, if you want to know the population of an area, you might get a decent idea, estimate, by looking through the telephone book. But just the names and phone numbers really don't give any meaning to it. You have to interpret the data in order to give it meaning. And interpretation is not a matter of experiment. Interpretation is a matter of a kind of a philosophical approach. How do you interpret this? And it can be very subjective. So giving it meaning is coming beyond science. It's not coming from the science itself. It's coming from beyond science. So let's talk about meaning in science. Science has discovered many facts about nature. It's marvelous. I love reading about, and I think probably you do too, the latest scientific discovery. It's just great to see what's been discovered. And we ooh and ah many times. But all those facts don't help me at all to know how to live, for example, or whether my life is worthwhile. That meaning comes from what we call our worldview. There's a worldview called scientism. Scientism is the view that only science provides true knowledge. And if you haven't seen that view expressed, you probably have just overlooked it, because it's commonly expressed. Many of the leading voices in our culture have no use for any kind of knowledge except what science has discovered. Have you noticed that? Keep your eyes open as you listen to the news, read the newspaper, watch the television. People talking about science. Do you ever hear them talk about knowledge from other sources? Maybe science isn't the only way to know. It depends on who you listen to, but there are many who take that view. And they often deny logically that there is no meaning in life. We'll look at some examples. George Gaylord Simpson, who's now deceased, was he was one of the architects of what's called the Neo-Darwinian synthesis in the 1930s and 40s. He was, in his day, the most authoritative, most famous paleontologist in the world. He was very influential, wrote several books, had a very distinguished career and a very powerful position. In 1949, in the book, The Meaning of Evolution, he wrote, "Man was not planned in an operation wholly planless." He wrote another book, The Meaning of Evolution, later in 1967, and just to make sure you didn't miss the point, he made it more explicit. He said, "Man is the result of a purposeless and natural process that did not have him in mind." Now think about that statement. What does it mean? It means man's an accident, right? It means man's an accident. Now, is that a conclusion based on scientific evidence? Does Simpson have any scientific evidence to point to say man's an accident? No, that is not a scientific statement, even though it's made by an eminent scientist. It's a philosophical statement, not a scientific statement. It is not based on data. It's based on his own subjective belief about how the world is. Here's another one. Jacques Monod won the Nobel Prize for his discovery of the lac operon in bacteria, a gene regulatory system. He wrote a book called Chance and Necessity. And this is, I think, I don't know if this is the last paragraph, but it may be the last paragraph or close to it. "The ancient covenant is in pieces. Man knows at last that he is alone in the universe's unfeeling immensity, out of which he emerged only by chance. Wow, what a depressing feeling. There's no science behind that. This is a man who has chosen a worldview that excludes God, and he's expressing his belief about that world in this way. Another example is William Provine, a very famous, I think he was a paleontologist. No ultimate foundations for ethics exist. In other words, morality is not absolute. No ultimate meaning in life exists, and free will is merely a human myth. Do you believe that? Have you ever made a free choice? Provine would say, no, you're just a bio-robot. Your genes are programming you, and you think you're choosing, but actually it's your genes who are doing it. I don't believe such nonsense. I don't think he believed that either. If he did, he would have to admit that he had no choice in making that statement. A recent survey just this year, I put this in because I thought it was quite interesting. What do believers and non-believers think is of value? See, this is meaning in life. What do people think is meaning? From Brazil, China, Denmark, Japan, United Kingdom, and United States. Family and freedom were the overwhelmingly in this survey between atheists, agnostics, and believers and the general population. Freedom and family were overwhelmingly the most important values. Other values that were lesser on the list: learning, nature, compassion, justice, science, and truth. I noted that none of those groups ranked science in the top 3 for value. I thought that was kind of interesting. What people really value is not science, but people, right? People, freedom, family, relationships, that's what's of value, and that's something that even unbelievers and believers agree on. Well, there is meaning beyond science, and I would propose that the Christian worldview provides a satisfying and coherent understanding of the meaning of life. Life has meaning because we are valued by our Creator, and He has a purpose for creating us. That gives us value. That gives meaning to life. It has really very little to do with science. We get that famous text, probably, I suppose it may be the most famous text in the entire Bible. For God so loved the world that He gave His only begotten Son, that whoever believes in Him should not perish but have everlasting life. That gives meaning. There's meaning in that statement. My life has meaning because God gave Himself to save me. And the same for you. Your life has meaning because God loves you and gave His Son that you can live. Science in a Christian worldview provides evidence of intelligent design and reinforces the Christian teaching that God is the Creator. So that's the answer. The question is, what's the role of science in the life of a Christian? Is it of any value? Yes, it's a great value, not only for our comfort, but also for our meaning, because as we look at science, we see the intricacies of a cell, and we say that could never have occurred spontaneously. And in fact, it's even beyond our capability to produce ourselves. There must be a real engineering genius, a nanotechnology to create a cell. So without science, we've never known about the bacterial flagellum and the structure of it, or about the molecular machines that operate in our cell, the ATP transferase and ATP synthase. It also reinforces the Christian teaching that God is the Creator, because we see the skill, the power, and the the knowledge necessary to create life is something that it just requires a supernatural, especially if you think about the origin of the universe. Maybe we'll have a chance to talk about that tomorrow. All right, so in conclusion, first conclusion, science has been highly successful. You know, as a Christian, we may be threatened by what scientists say about Christianity. But the science is not the problem. It's the worldview of the scientist. It's the materialism. That is the belief that there's no God. That's where the problem is. But science has been very good, and largely due, I think, to the experimental method and to the care that's been taken in practicing science. Second point, science arose in a Christian context. It has some roots in Greek philosophy, but modern science only developed in a Christian culture, and Christianity provided the logical foundation for practicing science, for the development of science. Most of the early pioneers of modern science were Christians, as I pointed out, with a list of the founders of biology, the founder of physics, the founder of astronomy, founder of chemistry, so on. Third conclusion, science has both strengths and weaknesses. If science is defined to be purely naturalistic, the way materialists want to define it and are struggling to define it, if that's the definition, then it cannot be taken as an authority on activities of God, such as singular activities especially, such as creation. If they deny the supernatural, then they have nothing to say about the supernatural. We find no conflict between experimental science and the Bible, and I think that's a point worth emphasizing. In the experimental science, we find no conflict. The conflict is when we tell stories about the past. That's when we get into conflict. Science alone cannot provide meaning for our lives, but in the hands of a Christian, science can help reveal God's power in creation. There's great benefit in science. And so the final conclusion is there is more to nature than science can discover.